And the last thing we're going to look at is just a couple word problems. And in some ways, these are actually going to be easier than the solve problems because you don't have to find every single piece. You only have to find what the problem asks for. So you just have to pay attention to the question here. So we have a surveyor needs to determine the distance between 2 points that lie on the opposite banks of a river. The figure shows that 300 yards are measured along one bank. The angles from each end of the segment to a point on the opposite bank are 62 degrees and 53 degrees. Find the distance between A and B to the nearest foot. So that's our question right there. So you need to go to the picture and find A and B and call that distance X. So then if we look at the setup here, we have angle, side, angle, which tells me that I can use the law of sines to solve this problem. It's one of the cases where we can use the law of sines. And then we just have to set it up. So if I want to find x right now, I'm going to start with the angle across from it. Sine of 53 over x is equal to the sine of, here's our problem. We have the 300, but we don't have this angle across from it. So you are going to have to do a little bit of math there to find that angle. Add the two angles that you know. That's going to be 115. Subtract from 180. You get that angle is 65. So just make sure you're using the appropriate angle in order to be able to use that 300. So it's sine of 65 over 300. And then we just cross multiply and solve. 3 times the sine of 53 is equal to x times the sine of 65. Get rid of the sine of 65, divide that to both sides. And then your calculator again will do all the work. Type that in, and it says round to the nearest foot, so you should get an answer of 264 feet. Let's try another one. So let's take a look at this next one. It says to find, we have a pier that forms an 85-degree angle with a straight shore. So it's kind of going off at an angle. It's not perpendicular. At a distance of 100 feet from the pier, the line of sight to the tip forms a 37-degree angle. Find the length of the pier to the nearest foot. So we're trying to find the length of the pier, which in this problem they already called that A. So we're trying to find that side right now. And so if we look at what they gave us, so far we have an angle and a side of the triangle, but I need another piece inside the triangle. So your first step here is a little different. We need to find what this angle is here, this inside angle. Since we know the angle next to it, if you look at, we have a straight angle there, we can just subtract from 180 minus 85, and it's going to tell me that this angle is 95. So that now tells me I have an angle side angle problem, which tells me I can use the law of sines. So it's going to start as sine of 37 over A, because those are across from each other, equal to, same problem here. I don't have that angle across from 100. You need to find it. So we're going to take the 95 and the 37 and add them together. That is 132. Subtract from 180. It gives me that top angle should be 48. That's the one I have to use in my proportion because the 48 and the 100 are across from each other. Then we just finish cross multiplying. 100 times the sine of 37 equals A times the sine of 48. Divide by the sine of 48 to move it to the other side. And type that part on your calculator. And you should get, again, it says round to the nearest foot, so it's going to be 81 feet. All right, one more. This last one, we have a leaning wall is inclined 6 degrees from the vertical at a distance of 40 feet from the wall. The angle of elevation to the top is 22 degrees. Find the height of the wall to the nearest foot. So if I need to find the height of the wall, they actually already labeled it there. That's what we're looking for. The wall is leaning though, so it's not straight up and down. This is not a 90-degree angle, which is why we can't use SOHCAHTOA. We have to use either the law of sines or law of cosines. So we look at what we have so far. We have an angle and we have a side. We need another piece of information inside the triangle. So we really want this angle here. So we have to work with what we know. We know that this little teeny tiny angle is 6 degrees. And I know that this big angle here is a right angle. So I can do 90 minus 80 minus 6. Sorry, my brain jumped ahead. Minus 6 is going to be 84 degrees, and that's what goes inside the triangle. So now this is, again, angle, side, angle. So we know we can solve the problem here. And we're going to start with the sine of 22 over b is equal to, look at this again, we don't have this top angle, we got to find it. We got to use the two angles we know. 84 plus 22 is 106. Subtract from 180, we get 74. It's the sine of 74 over 40. And then we cross multiply and solve. 40 times the sine of 22 is equal to b times the sine of 74. Divide by the sine of 74. Divide by the sine of 74. Type this part in your calculator, and it tells you that b is rounded to the nearest tenth, 16 feet. Or nearest foot, 16 feet. So I'm going to give you 2 problems to try in class kick, and then you need to do the homework that's been assigned for over the weekend. The class kick code will be R3855K.